Okay, question is this continuous? 1 over x minus 4 at x equals 4. Now, implicitly, that's function f of x equals 1 over x minus 4. If we apply the definition, as we did previously, we see that the test is the limit as x goes to 4 of 1 over x minus 4, which is the limit as x goes to a of f of x, equals the value of the function of 4, 1 over 4 minus 4. Oh, that would be 1 over 0. That's undefined. Well, the definition of continuity can't be verified, so the function is not continuous at x equals 4. We can't verify the continuity because this limit cannot be an undefined quantity. So, function is not continuous at x equals 4. So that one is kind of cut and dried. Okay, another example. Function that's defined to be x minus 2 on the interval from negative infinity to 4. In other words, for x less than or equal to 4. So that this function applies up to and including this point, which I've darkened a little bit more to indicate that that point is included on this part of the definition. And then y equals 6 minus x for x greater than 4. Now we can verify that when x equals 4, x minus 2 is equal to 2. And when x is 4, 6 minus x is equal to 2. So that these functions do meet at this point. Okay, well, how do we define the limit? In this case, we look at the limit of the x minus 2 function as x approaches 4 from values less than 4. And then we look at the values of y equals 6 minus x as x approaches 4 from x values greater than 4 and see what the limit of that would be if we approach it from values greater than 4. So when we approach from values less than 4, we call that a lower limit. And we call that the limit as x goes to 4. We put a minus there indicating x approaches 4 from below. So x is approaching 4 from numbers that are less than 4. And for numbers that are less than 4, then f of x is x minus 2. So we're finding the limit as x goes to 4 from below of x minus 2. Well, it's very clear that the closer x gets to 4, the closer x minus 2 gets to 2. So if x is 4.001, x minus 2 is 2.001, very close to 2. And the closer we let x be to 4, the closer our result is going to be to 2. So we can say that this limit is 2. The limit as x goes to 4 from above of f of x is the limit as x goes to 4 from above of 6 minus x. Since for x values above 4, to the right of 4, x values greater than 4, y equals 6 minus x. So we calculate the limit of the 6 minus x function as x approaches 4 from above. So if x is, for example, equal to 4.001, 6 minus x is going to be 3.999, and you can verify that. You need to play around with numbers like that to convince yourself of why this 6 minus x does approach 2 as x gets closer and closer to 4 from above. Now up here I use the example of x equals 4.001 because it was easy to subtract 2 from 4.001. And that wasn't really a good choice of x because we're supposed to be approaching for x values lower than 4, less than 4. So I could have chosen 3.999 so that x minus 2 would have been 1.999. Again, close to 2, and it should be clear that if we let x get even closer to 4, x minus 2 is going to get even closer to 2. In any case, we verify then that the lower limit is 2, the upper limit is 2, so now it makes sense. The lower limit equals the upper limit equals 2, so the limit is equal to that common value of the lower and upper limit, which is 2. The limiting value of the function as a whole is 2. So the limit of f of x as x approaches 4 is equal to f of 4, because this limit we've just seen to be 2 at f of 4. Well, let's think that through. If x equals 4, then the function is defined to be equal to x minus 2, since x minus 2 is the expression that applies when x is less than or equal to 4. X being equal to 4, this applies. We get 6 minus 2, which is 4. So the value of f of 4 is 2. The limit as x approaches 4 of the function is 2. It follows that f of x is continuous at x equals 2.